Okay, let me move out the screen. Oh, look at this. Okay, I hope this can be seen from your screen. Okay, let me present this. Okay, so this was supposed to be introduction because we only have 1 hour, right, for this week, and I think Friday is holiday, right? So we will see each other again next Wednesday, and next week we will just have just one class. Okay, this is it. I'm just finishing my quarantine actually, so next week should be okay. So as an introduction, I would like to just discuss on what we are going um, to achieve, or at least what we are going to do for the whole semester. So okay, let's start. I think you already know my name. So okay,
Okay.
but this is just for the recording. My name is Iman Adi Purnama. I'm already teach at NTUSA already, I think, almost 4 years. So welcome to the class, and this is the first time I teach the polymer chemistry. So I need to settle down on mapping which part that I need to teach, and I need to know like the the students also in the class, because I think we only have less than 10 students. So I think because we only have a small group, so we can actually, I hope we can um, progress. I'm not saying quickly or fast, but I would like to say I hope we can progress proportionally. Okay, as long as we know our directions and which part that is really fundamentals in polymers. Because if you study polymer, as I remember, they are really vary a lot. Like um, even you cannot really memorize everything at once at one semester. Actually, you cannot really memorize everything. But if you can memorize like some parts, I think that's okay. But what I want you to have is the basic sense, the common sense in the polymer science and chemistry. At least that is the main point for our course. Okay. Um, I think that's just my introduction. So polymer chemistry. Okay. So it's supposed to be the introductions for the course. So it has two words. It's a polymer and chemistry. So I hope chemistry is easy to follow because expected to be already learned, right? Already passed, and fundamentally is important for science, especially if you want to move to next sections on your engineering. Like if you pursue chemical engineering, material science, there will be much chemistry and also polymer inside. So that is one way to look at this courses. And polymer means that of course you heard on polymer many times, especially when you learn chemistry. But what we are going to look on this polymer chemistry is what is the fundamental things on polymer that is related to chemistry. How basically most of them are the important thing is how they can polymerize and what kind of polymerization they can have. Like we have several sections on that, and I think polymers, because it's really broad subject, and of course it's evolving, like every periods of time it's evolving, because there will be a new polymers, a new way to create. Okay. And because of that, uh, polymers are one of easiest tools to recreate new materials. Okay. That's the other way that we can observe the polymer. So we are going to look at polymer and its process, which is basically a chemistry. Okay. So what do I mean by these two words here? It means that there are several parts in your chemistry that you are going to review, or at least you need to look back to your chemistry, at least how to set up the name, uh, the functionality, and so on and so forth. That is really basic in chemistry. We will going to look for in our course, and by that means is I will not focus like you need to memorize this blah blah blah, but you need to have like a good structure, and you know which part that is going to be uh, like, for example, you have given some polymers and you want to have how to polymerize this with this, and which part that are going to cut, which part is going to connect each other. So that will be my goal. Okay, my goal. So I'm not going to force you to like memorize everything, but you need to at least have a good understanding in the structure. Okay, in the structure. Okay. So that's polymer chemistry, okay, in a sense. Okay. And the textbook, okay, the textbook we have. I'm using the first one. It's called the uh, Polymers, Chemistry and Physics of Modern Materials. It's by Koei and Arigi, the third edition. That will be the main textbook, which means the main topics should be derived from that textbook. But I will also pick some content, some materials from the other textbook as well, especially the second one and the third one. The second one is the Seymour Caraher, the sixth edition. It's quite thick. It's quite a lot content, but it's giving you some details informations. For example, they give you some summary on uh, which method you are going to have in your basic chemistry. And they already summarized in the book, so it's really helpful. The third book, not really, I'm not really going to use a lot. The Hemans and Lodge, the polymers chemistry. But I will use a lot for the first book and the second book. Okay. The fourth book is more like comprehension of the polymer science and chemistry. It's not really long, and it's really like a short version. It's good for a summary, but I think I will keep the main topics on the first textbook and some additional on the second textbook. Okay. Now, the scoring system. Uh, well, I'm planning to have like usual a quiz and a homework if we have homework. But homework, I think homework will be like a project. Like you can write some report on something. Like on we are going to discuss the homework part. So each of students will have different topics. The topics can be the polymer itself, maybe different polymers, or maybe the process itself, or maybe some phenomenon itself, and then you can write on the homework. And the homework probably what my plan is before midterm and after midterm, at least there will be two homeworks before and after. And then the last thing is the midterm and final exam. Yeah, I think this is just a standard scoring system, and I see now we have 3 students. So this week is online. So next week we are going to offline. Okay, just going to the classroom. So, so sorry if we are having online class today. I'm announcing this morning. And Friday, no class, right? Because a holiday, Friday. So we are going to meet again in the classroom on Wednesday, right? Okay. So this is the scoring system. As I mentioned, because I won't really uh, push you to memorize things, names, okay? So I think it's safe to say that in the midterm and the final exam, I will give you a chance for preparing some uh, like a cheat sheet, like one paper, and you can prepare everything over that paper. So I believe that will be helpful for some analytical questions that really needs to look on how the polymers behave. Okay, so that is the scoring system. Today's class will be very quick. Maybe 6 past 10 will be over. So schedule. I think the class is confirmed, right? 5:09 in your system, also 5:09, I think. Uh, and then we go to the syllabus. The syllabus is basically my expected results. It can be faster, it can be slower. It depends. And if for some topics it might be skipped, it might be offered. It depends on our class. But some topics that, for example, the step growth, the free radical, and then the linear copolymers or ionic polymerization, that will be uh, fundamentals in the polymer chemistry, because if you want to understand the polymers, at least you need to know what step growth mean and what free radicals means, okay, in the polymerization process, okay. And I'm trying to make this syllabus using the first textbook. However, the other textbook, like the second one, the Karaher, uh, they have different order, and I can see why those two books differs. But I think I can interject some of the other textbook in the middle of the lecture so that we can see some additional information as well. So I think it's still okay for the syllabus, and how fast we are progressing. It depends on our class. Okay, so for example, if the step growth maybe only need to two class, that means the next class maybe we can jump to this free radical, and then I'm mentioning this is quiz 1, quiz 2, and probably if um, I'm still thinking whether the quiz will be um, just online quiz, like I will give you the platform and then you can just click the platform, or we can just doing the quiz in the class. For now, we can just do quiz on the class, and it's just taking. I think this 28th, 14 October, they are all the Wednesday class, so 1 hour. So I think 1 hour we're focusing on quiz. I think that's still okay. And then after that, the ionic linear copolymers. Learn the copolymers. What is uh, the importance of copolymers? Why we need to make these copolymers? Okay. Why the copolymers makes the process easier? Yeah, I think that will be the topics. And then stereochemistry. Okay. Well, the stereochemistry, maybe I will explain a little bit on the before we going to this step growth, or maybe around this polymer intro, maybe next week, for some little information, because I think stereochemistry is basic, right? It's basic, but why it's important to understand the stereochemistry in the polymerizations. That will be the topics actually. The next part is it's actually after the midterm. The topic is more like an additional. It can be switch. It's not really um, fixed, uh, and they are all like not really that fundamentals. So I will just tell you now that really the fundamentals one for polymerizations, like polymer chemistry, like the core concept is the first, the before midterm. That will be the really important things. That is really fundamentals. It's supposed to be a little bit abstract and difficult to understand, but eventually, if you know, like, you can develop like how this process can get in, and you can like describe. I believe that that is the goal. But this one is more like it depends on the subject, like polymers in solution, polymer characterization. It's like small subject, but we are going to see like each topics. And then we see that we have other as well, rheology, the mechanical properties, how the viscosity and so on. Um, Stabilizers, reaction of polymers, there are some reactions. And then polymer technology and special topics is more like the topics that are trends in some period of time, and then we can discuss more on those topics here. It's actually quite a broad, like many topics, and then in one one big topics here. So it's like it's describing several topics as well. Okay. So quiz 3 and then final exam. So yeah, it's actually every topics like from this week 12 is uh, not really that much in a sense. So, or I just give you like the summary in the class, but the rest of the details you need to observe and browse by yourself. I think you can look for the PDF of the textbook, I think easily, um, and you can try to check this all these sections. Okay. Okay, that's the syllabus. And then the next thing is I just want to know from 1 to 3 students. I would like to know whether you have taken the organic chemistry or physical chemistry. I just would like to know. If you have, yeah, have you taken? If you have you passed or maybe still fail, and then you need to still pass in the next semester? I would like to know. Okay, if you want to go to this slide is in your browser, you can go here to menti.com and use the code 81949200, or let me copy through here. Let me copy through the chat. If you want. But anyway, I know one is, I think, Palace, right? This is your answer, right?
Yes.
Yeah. Okay.
Hello.
Oh yeah, Tin. Can you
Hello.
can you answer here, Tin?
Yeah. Can I just answer directly, Professor?
Or you can chat. Use the chat box.
Oh yes.
Yeah. Okay, pass both. This is it Lee? Okay, Lee. Student Lee. Okay. Okay, good. Yeah, I just want to know like if you taken the organic and physical chemistry, so you know that uh, when you learn the physical chemistry, you learn that uh, the physical aspect on the chemistry, which means related to energy and so on and so forth. And when you learn the organic chemistry, you learn on the organic aspect in the chemistry, right? But in the polymer, we are not seeing that as like whether the polymer is organic or inorganic. It can be both. It can be both. Depends on what kind of polymers we are going to make, right? So I hope from your experience, if you have passed both this organic and physical chemistry, I hope from this polymer chemistry aspect you can get more knowledge to broaden your perspectives so that um, you know at least, okay, how polymerization works. Okay, you don't need to really know like all the process at once. You can just take the fundamental things first. What the very first concept that you need to to uh, to learn or to study for. Okay, and then uh, maybe expectation from this course. You have some specific requests or specific objectives that you are going to find. Like you want to know more about maybe some specific polymers or maybe specific like polymerization, or if you have any research project in mind, or maybe something that's related to your fields in the future, like maybe uh, industry. Okay? Well, I'm just curious, and maybe that will be maybe a project to work on for homework. Okay, probably. And well, if the homework can be done really well, maybe the homework, okay, I can exchange the numbers, the percentage. Maybe homework I can add more, and then maybe the midterm or finals maybe reduce a little bit, so you can have a good time for the project, and then you can. I hope the project itself is not like you are just looking at the article and then just copy the article and then maybe adding some picture. Well, what I want you to have in the project is you are going to look for, observe the materials, observe the content, and then cultivate the knowledge for, and then presenting into like a good report. I think that will be really good, and it's more original, right? Rather than just take the article and then not really read and understand and then just submitting. Still has a point, but if you write really original from yourself, uh, that's really good. I'm working with biodegradable. Okay, good. Biodegradable polymer. Okay, yeah, really good. Biodegradable polymer. Yeah, yeah, that's really interesting. Very interesting because the biodegradable, um, it's supposed to degraded, right? It's supposed to be degraded at some point, and usually the biodegradable is they deliver something and then they need to degrade at some point. So you need to know like maybe what factors that makes this polymers degraded, and how to degrade efficiently, like the with expected time. So maybe you need to degrade at 1 week, and you need to make sure that 1 week is degraded. Okay, like really you need to optimize that efficient, okay, the time, and then of course the materials itself. Okay, so I think that will be the end of our lecture. Okay, so I hope you can get at least a sense what we are going to study. But I think maybe before that, let me just show you just some slides, okay, from my slide here. This is just some tips and maybe what kind of review that you need to do. Okay, so let me close this. Let me close. Yeah, let me move my PPT, not PPT, it's just Keynote for Mac. Oh, where is it? It's gone. Wait. Why skip? Okay, now let me just go just a simple. Okay, so before we start like next week, um, this is I think one way to review, okay, the nomenclature, how to name the polymer, how to name chemical basically. So the structure, usually you have the order, right? What kind of priority, the priority, right? What is the number one, number two, number three, and then make it the name, like usually which part that has the functional groups, okay? So I hope you still remember that, okay? So that's the general rules, the seniority, the root, and then how to search. And then also we have the trade names, the brand names, and abbreviations. So I hope, because sometimes I will use with the trade name, sometimes I will use the other names. It depends on the context. If you are looking uh, at the supplier, you are looking the commercial name and the trade name. So it will be different because if you work on the lab and you work on like really looking at the chemical itself, sometimes the chemical just telling you the trade name, and then you need to look for what kind of polymers that is. And still, we need to look on like the standard procedure, and inside we can see structure, like the toxicity and everything that is related to your work on the laboratory. Okay, so yeah, I think let me go through a little bit, just to show you, uh, just the introduction, that is basically polymer is many poly, right? And the mer is part. So basically, like it's many parts. So there are one part that is repeated. Okay, basically that is polymer. And some prefer the term macromolecule. So what is macromolecule, and why people refers to the macromolecule? And the macro part is because the size, the size of the molecule, it can be, uh, for the masses, the molar masses, it can be from thousands to millions, and basically, we are dealing with the concept of giant molecule, and why people think giant molecule. So at the first time, uh, people were discussing and debate on why this happens. So people already have learned the knowledge on rubber, but they don't know the terms polymers yet. But they already know rubber, how they can make some plastic. They already know some of it. But to develop some terms that is polymers, that is not yet to be developed. And they still see that, uh, this is like a colloid, like, it has crystalloid substance, and it has the colloid substance. And if you see the diffusion process, the crystalloid, it can be diffused easily if you have solutions, but the colloid part, the colloids, it's refused to be crystallized, and they are really viscose, or it has the high viscosity, and they are diffused really slowly when you put in the liquids. So how do we understand this phenomenon? These crystalloids, why it's easily diffused is because they are having small particles. Like if you make a circle really small, and you can imagine that this small particle can diffuse easily, while the colloids, they have larger particles. And this is when people think and they need to know, like, there will be some part of the in our universe, in our world, that has the same structure, and it will let them to define the terms polymers. So they know from this colloids behavior. Okay, so I think the next part I will explain to you next week. So I will just stop until here. I'll stop here within this colloids debates, and then how they create the terms polymers. Okay, so the introduction will be a little bit having a story how the polymers works, and then after that we are going to more technical approach, the structure, the polymerization, and so on. Okay, so we will going through this first part as a really introduction and story, and then after that we are going to move on to the more technical approach for the fundamentals in the polymer chemistry. Okay, so I think that's for today, and we will going to see you on next Wednesday. Okay, so next Wednesday and Friday we are going to discuss in the introductions a little bit and a story, and on Friday we switch to introduction on the step growth. Okay, the step growth polymerizations. Okay, and every class I'm trying to record the lecture so you can review after class. Okay, so yeah, I think that's all for today. Maybe we can have a discussion if you have maybe suggestions or maybe feedback. For example, the project, like maybe you want to discuss, like you had some thinking on doing some project, like you want to know more about this and this, because maybe that part will be important in your industry. Like for example, the biodegradable polymer. Maybe you can be more specific what kind of biodegradable polymers that you are really passionate or really in research, or maybe you can know more, and then you can like share the informations to all of the audience. Okay, not really a presentations, maybe just the report, and then all the students can also see and read the reports. Okay, so you can submit to me first, and then I will share to all of you. Okay, and then you can read each other, and then maybe you can discuss things that maybe you are looking, and maybe you have something in common, and maybe working on in the same fields in the future. Okay, so I think that's all for today, actually. Okay, so is there anything to discuss or any feedbacks? I think we should have I think 6 or 5 students. I think in the Moodle, one student already told me that they are having problem with the schedule that is conflicted. So maybe some will be uh, maybe withdraw the course, but I'm not sure how many. Okay. So if there's no question, I think I will end the session. Okay. So we will going to see each other next week. Okay.
Okay, Professor.
Yeah. Is that okay?
Yeah, that's okay. I have no problems with that.
Okay, Palis and everyone. So I will stop the recording.